Okay. Does anyone need this sheet from yesterday? Yes, you do? Anybody else? We got one more.
I don't have mine.
You crazy person. Okay. So I want to, okay. So the vertical line test is does anyone remember, well, poor little Cheez-It? It will never beat. The definition of a function, what does it take to be a function?
Every input has one output.
Yes, every input can have only one output. There could be only one. That naturally leads to the vertical line test. When I draw a vertical line, that is one x value, and if it goes through more than once, that would be two y values for one x value. So the vertical line test is just a visualization of the definition of function. It's crazy. How are we doing so far? And if you think about it from the standpoint of functions have to represent something physical, if this was time, and this is where a ball is, then at this time the ball was here and here. That doesn't make physical sense. How are we doing so far? Okay. There's nothing wrong with a circle. A circle's great. But if I look at it a certain way in terms of these are time points and these are positions, it doesn't make physical sense. So it's officially not what we call a function. That doesn't mean it's bad. It just means it's not a function, that's all. It's just something else. Okay. So then we have multiple ways to determine. We have a visualization, vertical line test. We have this guy here where I just don't want to see any repeated x's. Yes? So can somebody tell me very quickly why this set of points would not represent a function? Why is that not a function?
2 points exist there at the same time.
Which things specifically?
Force.
Fours are fine.
Wait.
Fours are completely fine. Remind me, what's the definition of function? For every input, and what are the inputs? X's. There can only be one output. For an input of 3, what's the only output?
4.
For an input of 5, what's the only output?
4.
It doesn't matter they have the same output. That doesn't matter. Where's the trouble? Ones. At 1 second, I was both 7 feet that way and 3 feet back that way. Can I do that physically? Unfortunately not. That'd be great if I could. That'd be amazing. I can't do that shit. At least not that I know of. I've tried. Is that cool? Do you guys see that? So you just have to kind of remind yourself, when I give you a problem and say, is this a function? You have to slow your roll and you gotta go, every input can have only one output. That's what you're looking for. You know I'm gonna put multiple outputs of the same. That's a red herring. Don't look at that shit. That doesn't matter. You with me? So what's the shortcut when I give you this? If I see a repeated x value, no good. No bueno. How we doing? Okay, I like it. So in mathematics, when we name something, it's so, if I'm talking to one of my colleagues and I say, I've got this function, they know a lot about it. They're like, oh, you got a thing where everything you put in, you only get one thing out. So I don't have to say that. I just say, I'm working with this function. They know all that shit. You guys with me? You guys have heard of polynomials, right? That name means something. So if I tell my colleague I'm working with a polynomial, there's a ton of shit that I just communicated with one word. So we'll get there eventually, but okay, maybe. Okay. The most important thing about functions, I mean, this is important, don't get me wrong, but the most important thing is just being able to work directly with them computationally, right? The idea of This just means plug that in, right? Fundamentally, that's all functions are. Function notation is just substitution. So there was just one problem we left undone down here, I think. Or did I do this one?
We did it on. You did it on.
Oh, another sheet of paper. Go, Jeff. Okay. So what I want you guys to do, actually no, I'm sorry. I'm thinking about a different sheet. Let's look at this. This is very different from the other side. Actually, yeah, go ahead and try to do these first three. See if you can figure out what it is I want from you on those. Some of you guys did this yesterday. You got done with the first side and you turn around. Try to figure out what the hell I want from you. Did I tell you what the function is? But did I give you the graph of the function? So I gave you a lot of information. Let's see if you can figure out what I want for A, B, and C. So this is a get it or you don't. If you get it, you should be done. If you don't get it, you're like, I don't know. Does anyone know what part A wants from you? What's the input for part A? They input -1, correct? So the question is, what's the output? When you put in -1 into the function, what do you get out? So some of you guys might say, hey, Jeff, did you notice? You didn't give me aptitude. You didn't tell me what it was. How am I supposed to do that, right? I gave you something better. I gave you all the freaking answers. Where did they put the point for an input of -1? That must be the output, correct? So where's an input of -1? And the output is, there, done. The answer is 2. What must the output have been? It must have been 2, because that's where they put the point, yes? That kicks so much ass. So when I give you a graph, I'm giving you the answers. Say thank you, John. Okay. So what's this one? Yeah, for -2, the output was -2. So really what these things are saying is when x is -1, what's y? When x is -1, y is 2. When x is -2, y is -2. And what's f of 5? Good. 5, 0, right? So when x is 5, the output is 0. Kick ass. Now take a minute and do these next two. We did a problem like this. What's the domain and what's the range? Pretty sure we did a problem like that, right? Yeah, we did. You guys could do that. What's the domain? What's the range? Go for it. I'll stand here. Alright, so remind me, can somebody remind me the definition of domain? What's domain? Collection of all what? X values that have outputs, right? So collection of all the inputs. So is -3 a valid input? Why not? There's no output. So domain is a collection of all the inputs that have outputs. So what's the lowest input that has an output? -2. And do I include it?
Yeah.
Closed circle, yes. And what's the highest input as an output? 5. Because beyond that, there's no output. Shabow! What, what about the range? What do I look at now?
Y.
Yeah, the y-axis. So what's the lowest output that I get? -3 is the lowest output I get. And what's the highest output I get? 2. And I don't miss anybody in the middle, right? Everything between -3 and 2 happens as an output. Now I think yesterday we did this example where I had an open circle, a little bubble. So I had to throw that out, yes? So you gotta be careful. But here, every value between -3 and 2 is an output for something. Okay, I like it. So now I'm gonna turn this question around on you. What x values make this happen?
X equals 1.
Yeah, it's just one x value. So really what this is saying is, what input gives me an output of -3? Or even better, what x has a y of -3? So y -3, x is 1. So like -1 makes y 2. 0 makes y like a half, negative a half. 1 makes y -3. There you go. What x value makes the output -3? 1. Cool. Okay, I like it. Now, in general, if I give you a graph and I say, where does something happen? That's x values. Decreasing, or I'm sorry, let's start with increasing. If this is like profit of a company 2 months ago, 1 month ago, 1 month in the future, 5 months in the future, increasing, we would be happy because our profit's going up. So when was this increasing? What x value did it start increasing at?
-2.
Good. 2 months ago, we started to increase, yes? And of course, before that, I don't know, we lost the data. There was a fire in the warehouse, so leave me alone. When did it stop increasing?
1.
Now be really careful. Did anyone think to themselves, it stopped increasing at 2? But the answer for where is something happen is an x value. At -2 it started, so from -2 to -1, it was increasing. Do you guys see that? So from -2 to -1 is where it was increasing. So I'm going to answer that in interval notation. Is there anywhere else it's increasing?
Yes,
Where else?
from x1 to x5.
From 1 to 5 it's increasing. Do you guys see that? I'm not asking what was the profit or what was the amount of money. I'm saying where was this happening? That's x values. Yes?
Is it always going to be parentheses?
Well, the reason this is parentheses, can somebody tell me right here, right at that point, is it going up or down? Both, neither. Real quick, if I throw this pen in the air, give me a break here. I'm going to try to catch it, but this eye doesn't. I have 20% vision in this eye. So if I throw the pen in the air, right at the top, was it going up or coming down? Neither. Doesn't it go up and then stop and then come back down? It doesn't stop for like a while. I don't throw it up like, it's not like Wile E. Coyote or something where it's like, oh yeah, now we start to fall. No, you guys with me? But do you understand how it's going up? It has to stop for an instant and then it starts to come back down. So if my question is, where is it increasing? It is not frickin' increasing at -1. It isn't. That's where it's about to turn. So at -1, what's it doing? Nothing. It's just sitting there waiting. It's like, oh man. So at that point, it's not going up, it's not going down, it's sitting there for a second. Is that okay? Roller coaster. Up, flat, down. So you better be like not going up or down for a second if you're changing. Okay, maybe. Okay. I love you guys. Where's it decreasing? And do you guys notice that's the only thing we left out here? -1 to 1 is the only part we left out. So that must be where it was not increasing. We can see that it's decreasing from -1 to 1. It's going down. Okay. Let me stop for a minute. So far, so good? Let that be nice. It's like saying from 2 months ago to 1 month ago, our profits were going up. That's basically what we're saying. Okay. If I ask you, I don't know why I didn't ask this, what would our maximum profit be? Say like the y-axis is in thousands of dollars. What would our max profit be? Yeah, $2,000, yes? When did that happen? 1 month ago, yes? Okay. So when or where is x-axis, what was the value is y-axis. Okay, let me stop for a minute. Okay. When you get to calculus, everything I just said is going to be crazy important. What is the idea of this increasing? What idea does it have? This is a straight line, correct? This increasing, what aspect of the line does that tell me something about? The what of the line? Slope. So we're going to talk about slope here in a little bit later, chapter 4. Yes? So the slope, and calculus is all about, the first half of calculus is studying slopes of things that are not linear. Oh shit. Actual roller coasters. Yay! Oh shit! Yay! Okay. Sorry. Now down here, I already gave a situation, so don't blame me if you're like stuck. So it's okay. I don't know about this one. But if I give you a graph, could anyone consider a different situation this might represent? Why is this one a little weird? Because it's got some negative values, correct? But like I said, one way to interpret this is 2 months ago, 1 month ago, and then this would be predictions we're making, correct? Or it could be like 0 is noon, so -2 is 10 a.m. Do you see what I mean? So that question just, if I would truly make this into group work, I would have each group kind of come up with their own situation, and I want to show you the number of different situations that could actually be represented by that graph. Can somebody think of a different situation? I'm just going to put everybody on the spot. Can somebody come up with a different situation that graph might represent? Plant growth.
Maybe it grows faster at certain points.
So like, let me think. It gets a little weird because when it gets negative, does it mean it's actually shrinking?
Maybe.
Maybe. I like that. Yeah, maybe. Maybe it's like mold growth.
Sure, yeah.
Right? It's time to get up. Mold growth, and then you fight it for a while, and then you forget about it, and then it starts to grow again. So I like it. 2 hours ago, the mold started growing, and then you fought it, and then you kind of forgot about it, and then it grew some more. Yes. So maybe this could represent the rate at which it's growing and shrinking.
Yeah.
Okay, that'll work. It could be the temperature outside in Alaska.
Attendance.
2 hours ago, it was -2 degrees. Right now, it's -0.5 degree. In an hour, it's going to be -3 degrees. Do you guys see what I'm saying? Okay, I know in California, we don't believe that it goes below 30 or something, but it does. What's that? Attendance? Like, the...
Increase or decrease.
Or this could be
across
like
time.
the number of subscribers to my YouTube channel.
Right.
I lost 2, and then I gained 2, and then I lost 3, and then, you guys see? Maybe something like that. You guys with me? Which I don't care about because I'm not going to monetize the damn thing. I'll make $2 a month. Yay! Okay. Is everybody kind of with me? A little bit. Okay. So there's a lot to be gleaned by graphing an actual physical phenomenon, but also if you just have a mathematical function, if I graph it, I can see the whole thing at once, and I can figure out aspects of it. And in calculus, one thing we're going to do in this class a lot is we're going to graph things. Because in calculus, you need to be able to make a rough sketch and then do the calculus. The little rough sketch you make should be quick and easy. So one thing this class has to do is it has to make you analyze the hell out of graphs. So when you get to calculus, the graphs aren't a big deal. You can focus on the calculus. Does that make any sense? So you just be ready. I'm going to be graphing a log sketch. Okay. Graph everything. Okay. So, let's do this. By the way, before I forget, what's happening tomorrow? We have the first quiz. What's it on?
The lab.
1.5 and 2.4. That's factoring and complex numbers, yes? Okay.
Yay, Jack.
Okay. So let me ask you here. This is page 6 of the notebook. If you don't have the notebook, you can see it up here. Can anyone tell me the domain for this function? What kind of function is that? If you plug any number in, what kind of answer do you get? Do you see what I mean? All right, really quickly. I'm going to change the question. Given part A, can you figure out what f of 1? What's f of 1? What is f of 1?
7/5.
Yes, because be careful. I'm telling you to replace x with 1, so I literally just replace x with 1. 1 minus 6 is -5, so I get -7/5. Is that cool? Do y'all agree that most numbers I plug in, I'm going to end up with a fraction, yes? What can I not have happen in a fraction?
0 on the
I can't have a 0 and then no. Yes? Can anyone tell me what value I could try to input that would cause that to happen?
6.
Am I allowed to plug a 6 in then? Because what happens if I try to plug a 6 in? I get 7 divided by 0, I make a black hole, everybody dies. Yes? Don't do that. Just banned. So what's my domain then? Remember, what's the definition of domain? All the inputs that have outputs. Do you agree that 6 does not have an output because it's undefined? So what's my domain? What's the only number that's not in my domain? 6. Okay. So the domain of this thing, you can either say it in English. The domain is all real numbers except 6. Or you can be more mathematical about it. Everything from negative infinity to to 6, or 6 to infinity. So I just skip 6. From negative infinity to infinity, but I skip 6. So I want you to notice something. If I give you a function, an actual function, and I say, what's the domain? If you could just say to yourself, what can't happen, or what must happen, then I could figure out what the domain is. So like for part B, what can I not take the square root of and stay real? So normally, unless it says otherwise, we're always talking about real values. What must be true about the inside so it stays real? The inside can't be negative. So what must the inside be then? Don't say positive. I really want this to make sense. In English, what has to happen for this to be cool? The inside has to be at least what? What's the smallest number you can take the square root of? No, there's a smaller number than 1. 0. What's the square root of 0? 0. Because what do you multiply by itself to get 0? 0, yes? So doesn't the inside have to be at least 0, correct? So that is me saying in English what must happen. Can you write what I just said in Mathish? What's the inside? What's the inside? What exactly is the inside? 7 minus 5x. And what it has to be at least 0. How do I write that in Mathish? At least 0.
Less than.
No, that would be less than 0. Greater than or equal to 0. Can you guys solve that? Solve it. Go ahead. I'll wait. Those of you that have no paper out, you fascinate me. Doesn't make any sense to me. You're like, dude, I got it right up here, man. I'm like, damn, you're better than me. You should consider doing notes. Notes are good. There we go. Almost. You almost had paper. Okay. Good there. So what's the first step here? Subtract 7. So almost always when I'm trying to solve anything, I get the term with x in it by itself. This has x in it, so I'm going to get rid of this. Then what am I going to do? Divide by -5. Does anyone know what happens? Sure. But do you notice how I left the sign out of things? Do you guys remember what happens when I divide or multiply an inequality? Both sides by negative? You ready? Watch this. You ready? Are you ready? Okay, this is crazy. Which one of these is bigger? Holy shit. What if I divide by -1? Which one is bigger now? What did the sign do? So when you divide or multiply by negative, the inequality has to flip. Yes? Okay. So that tells me that if I try to plug in any number bigger than 7/5, my answer is going to be complex. It's not going to be real. Let me stop for a minute. Let me give you a related problem here. No, of course not. Sure. How would you figure out the domain for this guy? This is harder than the problem we just looked at that's in the book, in the lecture book. It's harder because it's kind of hiding. Can I make it show me the parts it has? What do I do to see what can't happen? What can you not have happen? The bottom can't be 0. Can I easily see the way it's written what makes the bottom 0? How can I rewrite this so I can see what makes it 0? Factor it. And how do I factor the bottom? You mean there's a purpose to factoring, Jeff? Yeah. How do I factor the bottom? X squared is x times x. How do I factor 18 correctly to make it work?
One of them
One of them's
is
got to be negative. That's true.
negative
Negative 6 and 3, yes. Negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3. So can anyone tell me what x values I can't use? What makes this 0? 6. So x can't be 6,
and negative 2.
and x can't be negative 3. So to be honest, this is an acceptable answer. The technical way to write this answer, which I feel is like overkill, would be negative infinity to negative 3, negative 3 to 6, 6 to infinity. Oh my god. So whenever I see this little thing, that means skip. So skip negative 3, skip 6. Because that's what I have to do. I can use everything except those two. So that's the interval notation form of it. It's just easier to say, don't use 6 and don't use negative 3, right? Don't put the fork in the outlet. Yeah? Okay. Is that all right? Okay, maybe. And it all comes from the fact that the way the function's written, the bottom can't be 0, and that inherently makes some x's not good. Let me ask you this question. What's this guy's domain? You guys notice you can't factor that, yeah? So think about it. The bottom still can't be 0, correct? I can't let the bottom be 0. What's the smallest x squared could be? 0. So what's the smallest the bottom could be? 1. Can the bottom be negative then? I need you guys to be with me. This is so cool. Can't factor the bottom. Shit. It's got to be a different way to look at this. X squared, the smallest is 0. 0 plus 1 is 1. The smallest the bottom could be is 1. Could the bottom be negative then?
No.
If the smallest it could be is 1, ain't no way in hell it could be negative. So what, do I have to throw anything out of the domain? So what's the domain? If I don't have to throw anything out, what's the domain? If I don't have to throw anything out, what numbers can I use? So the domain would be all real numbers. I could plug any number I want to in there, and the bottom cannot be negative. Any real number, yes. Okay. Do you guys see that? Alright, I'm not saying this is going to happen to you, but I just want to throw it at you. Bottom can't be 0, and what's beautiful is it's impossible for it to be 0. So no, so I can use all real numbers. Okay. Today's gonna be lecture heavy, by the way. So just, do what you need to with that information. Okay. So hopefully, some of you guys have this. I have one more copy. This section, if you don't have the notebook yet. Who needs it? Did you already get one of these? Anybody?
I don't know.
Did you share? Does anyone else need this?
I probably.
You guys?
Yeah.
So if you go over, you can share if you want to. Okay. Yes. Cool. So last time we did the beginning of this. We did this page here. I skipped this for the moment. We did all this business here. Oh my god. So let's talk about these. So this is kind of funny. This is just so you understand the way that they write questions. I really personally wish we had never done some of this. Some of this way of writing. If you see this, what that means is f of 1 times g of 1. That's just a shorthand way. They're going to say f times g evaluated at 1. So if I see this, I want to figure out what f of 1 is, what number is that, what is g of 1, and then I multiply them. Yes? If I had a minus sign instead of a times, I would figure out what f of 1 is, what g of 1 is, and then I would subtract. Yes? So, what do you guys think this means?
Both functions and
Yeah. Put f of x there, times, and so just multiply the two functions, correct? Okay. Thank God these means exactly what you would hope they mean. So can you guys take a minute and figure out what this is, given those two functions? Go ahead and figure out what f of x times g of x is. And then I'll show you two different ways to do this one. Oops, shit. Let's do this here, this here, this here. Okay. Sorry, guys. This here. Okay. That's weird. Okay. Okay. This one. Oh yeah, okay. That's cool. Okay, sweet. Alright, let me catch up to you guys. So when I see this, it literally just means take f of x, multiply it by g of x. So then what am I doing? Distributing. 35x squared minus 14x plus 20x minus 8. This is f times g of x. That is the function I get when I multiply the two functions they gave me. So there's actually two ways to answer this question. Do I have a function that is f times g? Do I have the f times g function? Did we figure it out? Yes. So then I can just plug a 1 into it. So go ahead and do that. Plug a 1 in there. So we're going to do the f times g function, and I'm going to plug a 1 into it. That kicks ass, because you just get 35 plus 6 minus 8. And what's that?
33.
That's crazy. Now, if I didn't have to do this shit, and that was the only question, I would do it this way. What's f of 1? What's f of 1?
That's 11.
Yeah, 7 plus 4, yes? What's g of 1?
3.
3. So what's f of 1 times g of 1?
33.
freaking 33, isn't that the same answer we just got?
Yeah.
Okay. I like that. Yeah. Do you guys see what I mean? Of course it's got to be the same damn answer because they're both answering the same question. Just one was a little more to the point than the other one. Do you guys see what I mean? I wouldn't do all this shit if the only question was this. I would have just done this. But since we had to do this, then I could just plug a 1 into the end of that one and be done with it. Okay, maybe. Over here, I multiplied an infinite number of numbers. And then I went, oh yeah, I mean when I have a 1. Over here, we plugged a 1 in first and just multiplied those numbers. The math don't give a shit which way we do it. Okay, that's why it came out to be the same answer. Here, so do example 10. Notice it's a minus this time, so same idea, except now it's all about subtraction. See how careful you guys are. There's a huge thing to be careful about. And you're all like, when is there not, Joe? There it is. Okay. Good. So this one says, a way to interpret this is f of x minus g of x. So then I literally, now here's the thing you gotta be careful about. Here's f of x. I'm gonna make a mistake. I have made a mistake. Oh no, I made a mistake. Does anyone see what mistake I've made? Or is this what everybody wrote down? I made a mistake. What am I supposed to subtract? What's the problem want me to subtract? It wants me to subtract g. What's g?
3 minus x.
I'm not subtracting 3 minus x. I'm subtracting 3. I'm not subtracting 3 minus, shit. So when I'm supposed to subtract a whole thing, I better put that in parentheses. So I'm subtracting the whole thing. And then what I have to do with the negative sign? Distribute. So then I get x squared plus 3x. Minus 3 plus x. And then I get who to what? Is that cool? So now I have an f minus g function. This is my f minus g function. So again, we have 2 ways to figure this out. I can either take my f minus g function and plug a 2 into it. And then I get 4 plus 8 minus 3 is 9. Or I can do f of 2 minus g of 2. Yes? What's f of 2?
10.
Yes, 2 squared is 4 plus 2 times 3 is 6. 4 plus 6 is 10. What's g of 2?
Negative.
Careful.
Or
1. What's 10 minus 1?
1.
9, holy shit. Okay, so I get the same answer either way. Of course, I get the same answer either way. Okay. Yes?
So why are we putting only one side in parentheses when we're subtracting?
Oh, if I put this in parentheses, is there anything in front of it that changes it? What's in front of it? A 1. And then if I distribute, so I don't need the parentheses because there's nothing in front that I have to show has got to distribute. But when I'm subtracting a chunk, I've got to subtract 3 and I have to subtract negative x. And I can only see that if I put in parentheses. So don't forget, oh shit, I'm supposed to subtract each piece of g. Okay. Hello. Okay. How's everybody doing? Now normally most students have worked with functions before. You guys have seen these functions before, yes? Maybe you haven't done like every little thing we've done, or you forgot. Don't let functions be, they're really not a big deal. Thank the gods this is exactly what it says. Just take the f function, subtract the g function. Yay! What do you think I do here? Holy shit! So notice the question. Can you guys set up what f over g of x is? Just take a second and set it up. Trust me, there's nothing you can do to simplify it, which is good. Oh yeah, I did finally get the video from yesterday to show up. Somebody told me, was it this class? The video, yeah, the video, there was technical difficulties I didn't realize, because I just get it started and leave. So if you ever notice the video's not up there, let me know. There's YouTube just burped, so it should be up there now. Today's video is going to be up there, eventually. So real quick, you should be done. What's f?
X squared.
X squared. Over what's g?
X minus 4.
I'm done. Yay! What's the domain of that function? Can you guys see it?
All real numbers.
All real numbers except,
Negative.
careful, not negative 4.
Oh, positive.
4, yeah. Sweet. Look at that. That kicks ass. So whenever I'm dividing two functions, my domain could change. Because whatever function's on the bottom, when he's 0, it's going to freak me out now. Okay. Remember? Real quick, what's the domain of g by itself? Can I plug a 4 into g? Yeah, what's the answer if I plug a 4 in?
0.
That's fine, right? It's not underneath anything. So what's the domain of g?
All real numbers.
All real numbers. What's the domain of f?
All real numbers.
All real numbers. I can square any number I want to. It's when I do f divided by g, things go to shit. Since one of them's on the bottom now. So what about g over f? What would that be? What's g over f?
All real.
What is this?
X minus 4 divided by X squared.
Now what's the domain? So this one is all reals except 4. What's this guy's domain? Except?
Negative 4.
No.
Plus 2 positive 0.
No. The top is cool.
0.
I don't give a shit if the top is 0. The bottom can't be 0. What makes the bottom 0? 0. Yes? So if I make it g over f, I can't use 0. If I make it f over g, I can't use 4. Because if I do that, I make a black hole rip existence out of reality instead. Okay. So this would be all reals except 0. In this case. So that's I added that question on in case anybody's like, where'd that come from? I just added it. I don't want to do that yet. Yeah, let's do this. Yeah, okay, beautiful. Then I can do this. Yeah. So I am, like I said, I'm very sorry to everybody. If you're like, I hate this guy's voice. My God, never do a podcast show. Today's gonna be a lot of me talking. Tomorrow we got that quiz first, and then I'm gonna have a worksheet based on what we're doing today. Thank you. Okay. My monitors just go off and on whenever they want. Very quickly, we already did this kind of the problem. Can you guys tell me example 14 there? Are there any of those that are not functions?
Yes.
The middle one, because what does it not pass? Vertical line test. So the volt is broken. X two are cool. Does anyone know what kind of graph this is?
That's a problem.
Parabola. What would the function have to have in it? X squared. In this case, it would actually be negative because it opens down. And if you forgot any of that, you're fine. That's in our future. Anyone know what this is a graph of?
An exponential graph? Absolutely.
Absolute value. Yeah. Okay. If you forgot, you're fine. Just wanted to see if anybody remembered. This one we've already done before. Yeah, we just did one exactly like this. If they give me the graph, they gave me all the answers, yes? Okay, so I'm desperately trying to get to something specific. This is a really good question here. Because we're going to start to transition between working computationally with functions and graphing functions. So, what the shit does it mean for a point to be on the graph of f? How could you tell if you don't have the graph? How could you tell if that point is on the graph?
Find the zero.
No?
And then the equation.
Yeah, what would you plug in? Yeah, what does this say? What 2 is the value of x, 2 is the input. So when you input 2, what has to be the output if this is a point of the graph? -1. Check it. Oh, wait. Input a 2 and see what you get out. Yeah, what do you get? 2 plus 3 is 5. 2 minus 7 is 5 divided by -5 is -1. So is that a point on the graph? Yes. And let me make this point. Since this class is going to be a ton of graphing, so if you really don't like graphing, okay. It's going to be a lot of graphing. What the shit do we graph things for? Is that a good question? Why do we graph shit, Jeff? If we're going to graph a lot of shit, why do we do it? Can anyone give me an answer to this equation? Can somebody give me an answer to this? You can do it. You can do it. In order to be an answer to this, how many parts does it have to have? How many variables are there? 2. So, let me give you one. You ready? Here's an answer. 1, 5. Do you guys see how that's an answer? If x is 1, what's y? 5. Okay, give me another answer. Give me another answer. 2, 6. Give me another answer. 6, 10. If I haven't heard from you yet, can somebody tell me an answer that I haven't heard from yet? Anybody? This is your time to shine. Come on. Give me an answer. Yes.
Was that 10 and then 14?
10, 14. Can somebody give me an answer with a negative number in it?
-2, 2.
Do it again.
-2, 2.
Kick ass, yes? I mean, how long could I do this for?
Forever.
I'll do this all day. Yeah, okay, so, and by the way, couldn't I use 2.73, 6.73? Do you guys see what I'm saying?
Yeah.
Couldn't I do square root of 11, comma, 4 plus square root of 11? I mean, how many answers are there? How many answers are there? Infinite number of answers, correct? every number you can imagine, you plug that shit in, you add 4 to it, you get an answer. You get like a point, yes? So, what if I said, give me all the answers to that? How long would that take you?
Forever.
Yes, forever, and then you bequeath it to your children to continue, and they go for the whole life, and then they bequeath it. You understand what I'm saying? So, if I need you to really get this. Since we do a lot of graphing in math, we do. I want every student to understand why we do it. And the most fundamental reason why we graph shit is it's the quickest way to answer the damn question. If I graph this, and this is ahead of us, but if I graph this, if I graph 1, 5, 2, 6, 0, 4, yes? No, Jeff, 4, yeah. And I just connect them, now I've given people all the answers. Just follow the line, yes? I don't have to make a list of shit. Just follow the line and you get all the answers. The graph is the quickest way to answer the question, what are the answers? Now, that's the most fundamental reason why we graph. And then there's so many other reasons why we graph. But that's the most fundamental. You guys see that? So just by itself, that kicks ass. I don't want to spend the rest of my life not even scratching the surface of all the answers. Yes? No, thank you. So whatever point that is it an answer to the question? Is it an answer to the equation? That point right there. This point right there. Yes. Don't even try to figure out what it is. That point, does it answer the equation? Does it work? Yes. That point.
No.
No. That point? No. That point? Yes. Okay. So all the points in the line work. Any point not on the line doesn't work. And of course, when I start having squares and absolute values and square roots, your thing gets all squiggly. It still means whatever the shit point it goes through works. Okay, sorry. There's a little tangent. Okay. So, here's what I want to focus on today. Well, the rest of the day. Piecewise functions. Anybody ever heard of a piecewise function? I think you have. Okay. Because your reaction was interesting. Do y'all agree if I shoot a missile, it follows, there's actually a function that determines that you can describe its flight path using, yes? And then that's what we do, is we can actually change the parameters in the equation and it's gonna move around, okay? Do you understand if it hits something, its direction suddenly changes? So what a piecewise function is, it says, oh, look at me, I'm going like a parabola, and then it hits something and goes, oh shit, now I'm going like a line. So it's like something happens and another equation takes over. Physically, it's just because, yay, bam, oh shit, something happened, something changed in the physical reality, yes? I throw a ball, parabola, somebody hits it, bam, different parabola, yes, going the other way, okay. But these trip students up big time. So look at this weird shit. So let's do this. This is kind of an awesome example to do this on, because if you don't know what something looks like in terms of a graph, do you guys remember what to create? I mean, how do I graph a function? Don't I make a bunch of points? You guys remember making XY tables? When is this function defined by 2x plus 6? When is it going to look like that?
X is less than -2.
For every input that's less than -2, correct? And when does -1 have x plus 3 take over? At -2, correct? If I make an XY table, what values do I plug in to use this part of it? Anything that is less than -2. Okay. So I'm going to make an XY table. This is going to be for 2x plus 6. Give me a number that's less than -2 that isn't crazy. A little less, not crazy. So let's do -4, -3. What do you get when you plug a -4 in? Let's see, we get twice -4 plus 6. Yeah, -8 plus 6 is -2. Is that cool? So now I've got a point. What point does my graph go through so far? What point does my graph go through so far? What's the only point I know that my graph goes through? -4, comma, -2. So I can plot that here in a minute. What do I get when I plug a -3 in? 0. So now I have 2 points that my graph goes through, yes? And you guys remember if I have a straight line, how do I know this is a straight line? Because the x is to the first power, yes? If it was squared or cubed or square rooted, it would be curvy somehow. How many points do I really need for a straight line?
2.
But I normally use 3 just to be sure. Now let me ask you guys this. Am I allowed to plug -2 into 2x plus 6? Let me make sure it moves with me. Does this function say I'm allowed to use -2 for 2x plus 6? If I have -2, what does this? No, it doesn't. In fact, what is 2x plus 6? Let me just give you a little warning. I'm gonna plug -2 in, but I want you to really know why. This says it's only f is only this if my inputs are less than -2. If my input equals -2, what must I use? This guy, yes? Now, real quick. Could I plug in -2.000000000000001 into this? Because it's less than -2, correct? Could I plug in -2.00000000001? What'd you do in math class? We watched our math teacher go, I'm sorry. So, let's see if you guys are cool with this. Remember what open circles mean? We saw one on that sheet, yes? It means that it doesn't really exist there. I'm going to have an open circle at -2. Where do I put it? I don't know where to put it unless I plug it in. So, I'm going to plug -2 in, even though I'm not allowed to. And to tell myself I'm doing something illegal, I'm going to put it in parentheses. What do you get when you plug a -2 in? 2. So there's going to be an open circle at -2 too because it's not defined there. But I still have to know where it wants to be so I can put an open circle there. What do I still have to do to fully graph this function?
Find just a couple points on the
I
other.
have to do another XY table. For this guy, you guys go for it. Well, let me give you a clue here. What's the lowest input you can use for this guy? -2. Do you want, now I want you to notice something. Whatever number you plug in, what's the first thing you do to it? Cut it in half. We're the humans in here, right? If you're not human, you can keep it to yourself. I don't know. You got a really good disguise if you're not human. We are all humans in this room, yes. I don't want to cut 3 in half. I need you to notice this. This is so cool. If you're trying to graph something, you get to choose what your inputs are. I'm going to input even frickin' numbers. I'm going to input -2, 0, 2, yes? Because then I can cut those in half easy. I don't have to plug in frickin' -1. There's no reason I have to do that, because if I just get a few points, I can connect them. You guys see what I'm saying? So make an XY table, -2, 0, 2, and plug it into the correct thing and try to get some points, and I'll catch up to you. Go for it. Oh, yeah, that's right. Eat some of my Cheez-Its. The lunch of champions. So you're doing an XY table, it should feel a little bit like function evaluation. You're plugging stuff in, right? Be really careful about the two negatives canceling out. What do you guys get when you plug a -2 in? Yeah. Half of 2, the negatives cancel out. Half of 2 is 1 plus 3 is 4. When you plug a 0 in, that kicks ass. You just get 3. And when you plug a 2 in, half of 2 is 1, the negative is still there. Negative 1 plus 3 is 2. So now, let's see if we can plot all this business. -4, -2, -3, 0. And then this is my open circle, -2, 2. You can see this makes a nice straight line. Gee-haw. This guy, -2, 4, 0, 3, and 2, 2. Waha. This is neat. Now, this piecewise function specifically kind of breaks reality. This is like I'm driving in my car, and then I teleported, and then I started going back the other way, right? I'm like, that was weird, so I went back home. Okay. So, I mean, this is not really necessarily a physical situation, but mathematically, there's not a damn thing wrong with this. One function took over at a specific time. The most common mistake I see students make, if you ever do a piecewise function and you end up doing something like this, what mistake is that a function? Why not? It doesn't pass the
Vertical line.
Yes. Does this pass the vertical line test?
Yes.
Yes. The one place it could have a problem, it only exists there. So it only goes through once. That's an open circle. So if you're supposed to be working with a function and the graph you make goes back on itself, you made a mistake. So the most common mistake is people graph one of the things too far. And then you're overlapping. It's not a function. Somehow your car is over there and over there. I don't want to be in that car. I'm not going to get a ride from you. I'll walk. Thank you. Okay. Or maybe that's kick-ass. Your little teleportation car. I like that. Don't hit us. Hits us? Oh shit. Okay. Look at this one. This is magnificent. You guys do this one. Call me or Christine over if you need some help. Yes.
The other example that we had back on the.
Oh, sure, yeah. Is that okay? So I want to point out one little thing, one little hint. This one never stops, yes? This one goes forever in both directions. What's the smallest input this one uses? Smallest x value this guy uses. So, what's the smallest x value this guy uses? -4. So it doesn't go that way further than -4. Do you see that? It doesn't exist for inputs below -4. So it's going to suddenly start at -4 and then it's going to do stuff after that. Okay. Okay.
I'm just kind
Yeah. What? Is this where it is? And that's at 4. Yeah. All the way there. And then it jumps to here. Yeah. Or it jumps to the next 3. Oh yeah, yeah. It's only here for a moment. And then it jumps to this one. No, no, no. Don't do that. Because these are not points on the graph. Just that one. So if you draw a line, you're saying all of those things work. And only that one point works. Okay. So let's see. Gotta be really, really careful with your negatives here. Plug a -4 in. -4 squared is 16. There's a negative in front, so that makes it -16. Plus 9. No, careful. So again, we do -4 here. -4 squared plus 9. Is that cool? But plug a -4 in. There's a negative, and then I got to square -4, and then add 9. What's -4 squared?
16.
And then you put a negative on it, yes? So what do I get?
7.
-7. Do you guys see that? When there's a negative in front of your x squared is positive, so my answer is going to be negative. So when I plug in -3, what's -3 squared? 9, put a negative on it, that's -9, plus 9 is 0. -2 squared is 4, -4 plus 9. 0 plus 9. 1 plus 9. I'm sorry, -1 plus 9, Jeff. Good job, buddy. 2 squared is 4, so -4 plus 9 is 5 again. Oh, I skipped -1. That's what I did. That's alright, Jeff. 3 squared is 9, negative 9 plus 9 is 0 again. And then I'm going to plug 4 in, even though I'm technically not allowed to. I have to know where to put the open circle. 4 squared is 16. Negative 16 plus 9 is negative 7 again. So let's see. Negative 4, negative 7. Negative 3, 0. Negative 2, 5. 0, 9. 1, 8. 2, 5. 3, 0. 4, negative 7. I'm going to put an open circle right there. So this should be expected. You all know, most of you guys said earlier, x squared is a parabola. Negative x squared is a down parabola. So this shape makes sense. It's a down parabola. So it goes, yeah. What does it do next?
If x equals 4, then it's 5.
And this is a single point, yes?
Yep.
This is the point x4, y5. So for just a split second, it's right there. Oh man, this is so math teacher of me to make you do this weird ass problem when you're on I'm awesome. And then what takes over?
2x minus 15.
Yes! So then I make another xy table. And this is just a line, so I just need a few points. Can I use 4? Not really, but I plug a 4 in just to see where the open circle would go.
It goes down to negative.
Yeah, what's twice 4 minus 15? That's 8 minus 15, negative 7. If I plug a 5 in, 10 minus 15.
Negative 5.
And when I plug a 6 in, 12 minus 15. Yeah. So 4, negative 7. It's an open circle there. 5, negative 5. 6, negative 3. And there's my. Now that was a trick. So this dude jumps up. Boom! He's there for a second. And then he's back and he goes down. Okay. Mathematically it's fine. Real world, whoever this is dead. Because they instantaneously went this way. He's dead. Poor little guy. It's okay. I know on one level I'm okay because I didn't overlap. It passes the vertical line test. Just whenever you're doing a piecewise function, when you think you're done, just make sure it passes the vertical line test. If it doesn't, you took one of these too far. They're supposed to stop and something else takes over at well-defined positions. Okay. Piecewise functions are the trippiest functions out there because they're actually multiple functions in one. Okay, maybe. But if you just do a separate XY table for each piece, that'll be so much easier. Okay. So this question kind of takes us backwards with this. This is a little bit evil, but let's see what you guys think. Let's see. We haven't really talked about slope and y-intercept and all that stuff yet. But I mean, what function, when x is -1, y is -1. When x is 0, y is 0. So what's the relationship between y and x? Y equals x. This is the function y equals x. When is the function represented by y equals x? When x is between -1 and 0. So, I could start to write. This function is x if -1 is less than or equal to x is less than or equal to, 0. So between -1 and 0, it's x. What is it between 0 and 2? What's the output? Everywhere here, what's the output? It's 1 if 0 is less than x is less than or equal to 2? What's the output for this input? 1. What's the output for this input? 1. So the output is 1 for every input between 0 and 2. Okay, I like it. You guys look appropriately excited, which is not at all. That's great. That's good. Okay. I don't blame you. Piecewise functions are kind of mean sometimes, but that's okay. You just got to take them part at a time. All right. Yes. The last thing I want to do is I want to get us to start thinking about. Oh, there was one thing. Hold on. Did I skip something? Oh, this guy. I'll come back to him. I won't do him right now. Yeah. All right. I want to lay some groundwork for. Do I want to go there yet? No. Hold on. I want to go. That's right. I want to go here. Yes. I want to go here. Yes, that's right. That's right. Okay, so maybe I can go there. We're doing it live. Hey, all right, sweet. Okay. So let me ask you this. Let's say this is time in hours, and this is position in feet. So at 0, let's say I'm at 0. And then at 1, let's say I'm at 10. And at 3, I'm at 20. Okay, this is exciting, Jeff. How fast was I going from 1 to 3 hours?
5 hours.
So 1 hour after, oh, I'm sorry, I should have connected these. So I start here, I go there, and I'm going there. So I'm going a certain speed, right? How fast am I going here? Now, on one level, some of you guys, I'm sorry, I keep cutting you off, but some of you guys may be like, how the shit would I know, man? You just do a line. How would I know what the hell? How much time did it take from here to here?
About 2 hours.
And how far did I go?
10 feet.
Yeah, I'm going slow, right? So it's like 4 o'clock on a Wednesday afternoon or something. You guys know there's certain times you just don't leave. You just stay where you are. Yes? Okay. Like give a couple hours of you. So how far did I go? 10 feet. How long did it take me?
2 hours.
2 hours. 3 minus 1 hour, so it took me 2 hours. So 10 divided by 2 is?
5.
That's crazy. 5 what?
5 miles.
No. 5 feet per hour. So I was going 5 feet per hour. Sounds about right when you're coming back home from LA sometimes.
That's acceleration.
It's not acceleration. Acceleration would be at the next level up, the slope of the slope. Let's not go there yet. I can, let me see. You guys remember, do you agree this is a function, first off? Is this a function what I've represented? Why? Passes the vertical line test, yes? At 1, the output's 10. At 3, the output's 20. So if I take the difference in the outputs divided by the difference in the inputs, I get an average, in this case, an average speed. What is speed? Sure.
Distance over time.
Sure, it's a change in distance, right? So it's, a speed is a rate of change of position. Oh, shit. Let me stop for a minute. This is a physical situation, yes? But I've represented it graphically. I've represented it mathematically, yes? I could have a function, just a function And I can ask similar questions. How quickly is this function changing? It doesn't have to represent anything physical. So let me show you what I'm talking about. What if I gave you this function here? What, Jeff? I don't know. Leave me alone. There. And I want to know what's the average rate of change of f of x from x equals 1 to x equal 3. So I'm not giving you a graph. I'm giving you the function definition. So since you don't have the graph, we don't have the outputs. Can you find the outputs?
Yeah.
Hell yeah. I want you to realize this is the same problem we just did. I'm just starting one step back. We don't have the outputs yet. What outputs do I need? Yes, when x is 1, what's the output? -1. When x is 3, what's the output? Let's see, 2 times 3 squared minus 3. 3 squared is 9, times 2 is 18, minus 1 is, minus 3 is 15. Yes. Okay, let me stop for a minute. You guys cool with that? Do you guys see how this is starting to bring together a lot of stuff we've been doing? Can anyone tell me how much the outputs changed?
14.
No? There. I don't blame you for saying that. You know, if I start at 1, at -1, and I go to 15, didn't it go up by 16? Okay. 15 minus -1, yes. Let me remind you. How did we get 10? Where'd 10 come from here? 20 minus 10. That's how much the outputs changed. Do I need a graph to see that? No. If I get the outputs, I can just subtract the damn things. How much did the outputs change? Jeff. How much did the outputs change? 16. How much did the inputs change? 2. So what's the average rate of change for this function? 8. For every one step on the x, from 1 to 3, it changed by 8. Now, do you guys agree this would be a parabola? Yes?
Yeah.
It would roughly look like this. So if I go from 1 to 3, what I'm saying is, if I just do that like a straight line, how much did it actually change? Okay, maybe. When you take a vacation, when you go on a road trip, do you go constant velocity for the whole time?
No.
Yeah, California is traffic. So let's pretend there's no traffic. Even though there's no traffic, do you go constant velocity the whole time? 8 hours on the road, let's do it. No, freaking stop so I can pee, right? Or I want to eat. Yes? But can't I get an average speed? I just have to say how far did it go, divided by how much time. So my graph might look like this, but if I do difference in the outputs divided by difference in the inputs, I'm doing like as the crow flies, I'm doing like the average speed I was going. So maybe when I'm on the road, I'm going 100 or whatever to LA like a crazy people. But I did a few stops and my average speed comes out to be 80 or whatever. Maybe, are you guys okay? So how do I want to show you. Given any function, holy shit, Jen. The average rate of change on x1 to x2. Oh shit. So like that would be 1 to 3. Yes? 1 to 3. x1 to x2 is f of x2 minus f of x1, the difference in the outputs, divided by x2 minus x1, the difference of the inputs. Now some of you guys might realize, what is f of x? What did it take the place of? What does f of x tell me? The y, kick ass. So isn't this the difference in the y's divided by the difference in the x's? And what is the difference in y's divided by the difference in the x's? Does anyone know? It's the what? y2 minus y1 divided by x2 minus x1. Slope. Isn't that the second output? y2, isn't that the first output? y1, y2 minus y, blah, 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 blah. So what's another name for slope? Average rate of change. Neat. Whatever you say, Jeff. So there's going to be some problems that they want you to figure out the average rate of change. They're going to give you a function. They're going to give you an interval. Plug those in. Difference in the y's divided by difference in the x's. You're done. Next problem. Okay, maybe. Maybe, maybe not. Maybe so. Okay. So that's here. I don't like. Well, we'll see. Yeah. We could do some of these. It might not be a bad idea. Here. This is an example you'll see in calculus. I have a function, there's too much going on here, but I have a function, and then I have an average rate of change.
What page is this?
This is page 40, believe it or not. So I don't know, if you go on the homework sheet, the first chunk that we're doing is for module 1, 4, and 5. I don't go in the same order as the lecture book, because I disagree with that. Nah. Okay. Don't worry too much. They're trying to infuse a little too much calculus in this. We might come back to this after we talk more about this directly. But just to show you, here's exactly the kind of problem that we would get. First off, net change is just how much did the outputs change. Average rate of change is how much did the outputs change divided by how much the inputs change. Can you guys go ahead and try to do this example? It's exactly like the one we just did. What are my inputs? Just to make sure everybody's on the right track. What are my inputs? 0 and 10. Good. Oh, good. Yeah. Okay. What have I done? This is what I did. Did you see how they've, T is like time, H could be like height, so this could be something somebody threw up in the air. So what's H of 0? 0. What's H of 10? 190, right? 10 squared is 100 times 2 is 200 minus 10 is 190. So if I do H of 10 minus H of 0 divided by 10 minus 0, that's the average rate of change. 190 minus 0 divided by 10 minus 0. What's 190 divided by 10? 19. So for every one step in the x direction, it went up 19 on average. Like if I climb a mountain, or if I walk up Coles Mountain, yes, have you guys ever hiked Coles, or if you say Cowles, I don't know how you guys say it. You don't constantly go up at the same rate. You got all these switchbacks, but sometimes there's a little bit of a slope. If you ever went up, there's in Poway, there's one called El Capitan, because part of it looks like something in Yosemite. The beginning of it is stupid steep, and you're like, oh god, and then it's not too bad. But I can average it out. I can say, what was my average? So it ignores all the ups and downs and just kind of smooths it out. That's what we're doing. Look at the beginning, look at the end, what was the average? In the middle, I could have been going up and down. Yes? Okay. In fact, I know this thing. What's this thing doing? Is it straight or is it curvy? Pretty curvy, but we smooth it out. We say, what's the average change? Okay. I like it. Now look at these. Let's do one more and then I'll let us out of here. Let's do this one. Because it's got big ass numbers. This one's really, 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 really nice. Because they don't give us a graph and they don't give us a function. They do something better than both of those. They just give us the numbers. You guys see that? And one thing I want you to realize, well, let's see. Can you write this? Well, all right. Can you write this like 2 points? What's 1 point of data?
Date.
1980 1718000. What's the other data point?
2020.
2020. In 2020, so the output in 2020 would be 325100. I'm just not going to put multiple commas because multiple commas make points look weird. So it's literally just the slope now. The difference in the outputs divided by the difference in the inputs. So can somebody tell me what's on the bottom?
19 or 2020.
Yeah, 2020 minus 1980. And on the top we got 325100 minus 1718000. Holy shit. What's that, math boy? Do that in your head. No. Leave me alone. I don't know. Let's see.
1,533,000.
Divided by 40?
Yeah.
Do it. You got calculators? That should go in. 3, 8. Something. Oh God, I can't keep it on it. What is this? This is 1537000. 153. No, that can't be right, Jeff. 1533. That looks better. All over 40. So that would be
Calculator said it was 38,325.
thank you. I knew it was 38 and then I got lost in my head. So that's 38,325. What's the units on this? What's the top represent?
Population.
People. What's the bottom represent? Years. So when we reduce it, we get this many people per year. Now, does that literally mean that every year exactly that many people came in? No, but we smoothed out the ups and downs. On average, that many people. Of course, you know, in 2020, I don't know if you know this, things happened. So it probably changed a bit, but we'll be okay. All right, I think that's enough. That's plenty. So don't forget, tomorrow, first thing, quiz. And then after that, a lot less talking on my part. I'm going to have a worksheet that kind of goes over stuff we did today. You guys can work together. All right. I will see you then. Here, Christine.